So please remember it. If you are asking to find the spectra, you need to get the square of the magnitude. Then you need to plot it with respect to k. And if you ask to plot the magnitude plot, you need to find the magnitude only. Magnitude versus k. Okay. Phase plot is the you need to find the phase of the ck. The phase is, you know, that tan inverse y divided by x. No, this is the phase of a complex number. No? Okay. So this phase with respect to k, that is phase plot. Okay. So anyway, you will not asked to draw the phase plot. Definitely, you will be asked to draw magnitude plot to power spectra. If you ask the magnitude plot, you need to get the magnitude of ck. If you ask to draw the power spectra, you need to get the square of magnitude. Okay. Alright. So we will move to the next one, sampling. Okay. So the first question is actually the related with analog and digital signal processing. Okay. So we know that. Okay. We know that if there is so you know that the real world is analog. Okay. Real world is analog. We know that. For example, our voice is analog in nature. Temperature, if you take temperature, this temperature varying is analog. And if you consider the height varying is analog. So all physical parameters are analog. Okay. And for example, let's say that you need to get our voice. Okay, so this is analog signal. Voice is analog signal. Okay. Now let's say that you need to do some filtering, equalizing, or amplifying. Okay. So so this analog signal you can get as analog value. Then you can apply an amplifier or filter, or you can do the signal processing. Okay. You can do the filter processing. Okay. So that is analog. Okay. So the input is analog signal. Okay. Then you are doing the analog processing. That means filtering, amplifying or something. Then output the signal. Okay. So that is also analog signal. But in digital signal, you know that if you need to process it in digital form, that means with few levels, 0 and 1 maybe. Okay. But the real world parameters are analog, have several levels. Okay. So you need to convert this analog signal into digital signal. No? Okay. So first there is analog signal. You need to convert this to the digital signal. For that one, you need to add analog to digital converter. Then after processing, so then you can digitally process it. Then after processing, you can't get the digital output. For example, if you have the voice, okay, if there is a microphone, you will be having the voice. Okay. You will be having the voice signal. So it will be analog signal like this. Then using analog digital converter, you need to convert it. Okay. Then you can do in the digital processing, equalizing like that. Then digital signal you can't directly feed to the speaker. You can't directly feed to the speaker. Before feeding the speaker, you need to convert the digital signal into analog. Okay, into analog. For that one, you have to use a digital to analog converter DAC. Then you can feed it to the speaker. Then you can get the real world uh, thing here. Okay. So here output the voice, input the voice here. Here you output the voice. The process is digital, but there are additional two processes, that is analog to digital conversion and digital to analog conversion. Okay. But although we have additional two processes, still this digital signal processing is easy. Okay. Because there are main three reasons are there. The one is uh, low power. The digital system will use low power. Okay. Low power. දැන් ඉස්සර කට්ටිය ඇනලොග් ෆෝන් දැකලා ඇති ඒක නිකන් gadol කැටයක් වගේ. Okay. Maybe lateral entry student have seen that one. So it is just like a brick. Okay. Actually, the circuit is not much big. The battery, that is the battery. The battery is very big. With that battery also, you can only take one or two calls. හරි call එකක් හරි දෙකක් හරි තමයි ගන්න පුළුවන්. battery බහිනවා. හරි. That means the analog systems are using high power. But now our phone is very small, no? Okay. Our phone is small. Actually, our battery is small. Now the screen is high. Okay. Multimedia access කරන්න screen එක ලොකුවට හදන්න ඕනේ ඉතින් තමයි phone එක ලොකුවට හදලා තියෙන්නේ. The screen, the phone dimension is that is depend on the screen, not the battery. හරි. battery එක ලොකුවට තියෙන්න ඕන හින්දා නෙවෙයි screen එක ලොකුවට තියෙන්න ඕන බඳ තමයි දැන් phone එක ලොකු. හරි. So anyway, it is low power. The first advantage is low power. Then the second advantage is the design and analyzing is very easy. Design and analyzing is very easy. Okay. Digital system design and analyzing is very easy because you know that ඔකට ජීවත් වෙන transistor එකක් පාවිච්චි කරලා මේ කැප් එකක් පාවිච්චි කරලා automatic circuit එකක් හදන්න කියලා ඔකට ඒක design කරන්න බෑ. We can't design it. Okay. We can find the circuit from the internet and we can implement the circuit, but we can't decide it. For the designing process, you need to know the characteristic of the transistor, characteristic of the capacitor, all things you need to know. Okay, with respect to the input signal. Okay, so you need to have uh, very comprehensive knowledge for that. But if you are given Arduino board, then if you are asked to do the very complex uh, circuit, you can do it easily. Okay. So the digital analyzing and designing is very easy. Okay. So that is another uh, another advantage. Okay. So in this way, you can compare and contrast analog and digital system. The advantage and disadvantage, then the additional processing. Okay, you can draw this block diagram and explain. Okay, okay. So now we are going to have the sampling. Okay, so this is okay. So here you can see that we are going to have the sampling here. Okay. So so there is a signal xt. Okay, there is a signal xt, and the signal is sampled. Okay, sampled to have a impulse train. Okay, so once you sample it, you will be having the impulse train. For example, okay, if there is a signal, if there is a signal, if there is a signal, sampling means you are switching. Okay, you are on this switch, then you will get a voltage sample here. Again switch off, again switch on another voltage sample like this. You will be having like this kind of signal. Okay, okay, and we assume that this switch is instantly off. Okay, so there is no duration on and off status. On, as soon as on, it is off. There is no duration. So these are impulse, no? Impulse. These are actually shifted impulse. These are shifted impulse. So this is the impulse train. This is the impulse train. Impulse train. You know the impulse, that is delta n. This is impulse. The shifted impulse means n minus k or something. So the impulse is like this one, delta n. Delta n minus k means this is shifted up to k. So here the k, the value will be 1. So this is the impulse and this is the shifted impulse. Okay. So these are some additional of shifted impulse. So that is referred as impulse train. Okay. So once the signal is sampled, you will be having the impulse train. Impulse train. So this is the discrete time signal. Okay. This is the discrete time signal. And here you have the continuous time signal. Once you sample, you will be having the discrete time signal. Okay. So if you can watch that lecture 1 and lecture 2, uh, we, we discussed the time domain sampling in very deeply, okay, but the frequency domain sampling is not included here. Okay, only we are considering the time domain sampling. Okay, so we will go to the question that is sampling. Okay, impulse train means the sampling that. Okay, and we have the signal. So the cutoff frequency is there because this is a low pass filter. The cutoff frequency is this one, so it will be uh, pass the, this is a low pass filter. Okay, so that is a low pass filter. Okay, so there is a low pass filter. Okay, and the cutoff frequency is given FC. FC is actually 25. Sorry, uh, FC is 25. Sorry, 25 FC is omega C. Okay, 25 FC is omega C. Okay, so FC is actually omega C divided by 25. Okay, okay. So this is so the cutoff frequency is given FC, and if you are input some frequency, the cutoff frequency means this is a low pass filter. Only low frequency will be passed. Okay, so the signals will be passed less than FC. Okay, the all the signal component less than FC will be passed. Okay, so that is means the cutoff frequency. Okay, so this is the maximum frequency that can be passed from this low pass filter FC. Right? Signal system just the common sense. Okay, common knowledge for engineering student. Okay, so this is then you are asking to find the maximum sampling period. Okay, so this is you have to use the, what is you have to use? You have to use the Nyquist theorem. Okay, so here I have mentioned the Nyquist theorem in the exam guide. Okay, so this is so for this one, just see the introduction part. Okay, the first chapter. Okay, that is enough. There is another chapter, sampling and reconstruction, but we are not the reconstruction part, and the frequency domain analysis is not here. Okay, so you can refer only the introduction part. In the introduction part, uh, there are some related, there are some stuff related to sampling, basic stuff. Right? Basic stuff ටිකක් තියෙනවා sampling වලට related. ඒවා ටික විතරක් කට්ටියට බලන්න තියෙනවා. අන්න මේක. හරි? එතකොට මේ equation ටික ඔකට දානවා, මේක n, මේ තමයි sampling time එක, this is a sampling time and this is the sample time. Okay, like this. Okay, this is sampling, so the signal is sending through a switch, as I told you. Okay, and once you sample, uh, uh, so here you can see that. Okay, so so if you have the continuous time signal, that is referred as xt. Okay, normal, the independent variable is t time. Okay, so you need to sample it. Okay, and convert this to the discrete time signal, that means xn. So you have sampled this. Okay, this signal should be sampled, this xt signal should be a sample. Okay, then once you sample it, okay, instead of this t, you have to apply n here. Okay, for that one, you know that this equation uh, oh, here I haven't written that one. No? Okay, so there is identity, the n is equal to uh, sorry, simple t is equal to n ts. This is the sampling time and this is the sample number. Okay, so please write this equation. This equation is also needed. Okay, and now you need to replace this t, you need to apply n. So t can be replaced by this term, no, using the nts. So you can use nts here. Okay, so you can see that t is replaced by nts. Actually, t is equal to nts. Okay. So ts 1 over ts means the frequency, sampling frequency. That means 1 over sampling frequency means ts. So instead of ts, you can put 1 over sampling frequency. So you will be having f divided by fs. So this is the signal frequency. Fs is the sampling frequency. So signal frequency is divided by the sampling frequency. It is referred as normalized frequency. Okay. And the normalized frequency should be between minus half and plus half. It cannot be larger than that one. To satisfy this condition, what we need to do? The fs we need to select at least twice than this frequency. No? Okay. So the fs should be higher than at least twice of the normal frequency. The sampling frequency should be higher than the at least twice higher than the signal frequency. So that is the Nyquist theorem. Otherwise, the normalized frequency will not be between minus half and plus half. Okay. So if it is minus half and plus half, it is beyond the minus half and plus half. There is another frequency. There is another frequency associated with that one. This is referred as aliasing. Okay. So actually, I have discussed the aliasing effect. I have visualized it using the MATLAB. If you have time, you can go through it. If you need to get the full understanding of this aliasing. If it is not, that is fine. Okay, we just see how to calculate the thing. Okay, but if you need to get the full understanding, you can see that videos maybe after the exam also. That is up to you. Okay. Um, so so that is how the aliasing is happened. Okay, so we have to select the sampling frequency. Fs is the sampling frequency greater than twice of the signal frequency, 2fs. This is referred as the Nyquist theorem. Okay, so you need to select the sampling frequency higher than at least twice of the signal frequency. Okay, otherwise it is not properly sampled. The aliasing effect will be there. Now what is the question? The very simple question is there. Okay, find the maximum sampling period that would be guaranteed extent can be recovered from this sample version. Okay, so we need to properly sample it. So what is we need to do? So this is the maximum signal that can be having by the xt. No, this is the maximum frequency that can be having by the xt. Other frequency will be lower than this one. And if we get twice of this one, the Nyquist theorem is satisfied. No? මෙන්න මෙයා වගේ දෙගුණයක් ගත්තා නම් Nyquist අනිත් හැම frequency component එකක්ම මීට වඩා අඩුයි. Other frequency component are less than 205 radian per second. Okay, so this is the maximum signal you will be having at the output of the low pass filter. Xt is the output of the low pass filter. So this is the cutoff frequency, and that is the maximum value you can have. So if you get the maximum sampling, you ask in the period, so you can find the sampling frequency, that is 405 radian per second. So this is the omega. This is the omega, and you know that. Okay, we know that the equations are given in the uh, exam tutorial. Okay, so uh, you know that omega is equal to 25 divided by n. This is the period. Okay, this is the period. Okay, this is the period. So you can write 25 by f. 1 over n is the normalized frequency f. Okay. Uh, so now you are given the omega, that is 405 radian per second. Okay. that is omega. Now you are asked to find the n. So n is what? 25 divided by omega, that is 405 radian per second. So here 25 also radian cancel. S will go out, up, okay. So you will have 1 divided by 400. So this is the period of the signal. This is the period of the signal. This is the period of the signal. It is in S, okay, because this is a second. Okay, this is not a sample number. We will have the answer with second. Okay, so this is the period of the sampled signal. This is the period of the sampled signal. Okay, so that is the answer for the question one. හරි තේරුණානේ කොහොමද හැටි ඉස්සෙල්ලාම sampling frequency එක හෙව්වා එකියට sampling frequency එක තමයි දැන් මෙතන ඇත්තටම sampling frequency එක නේ මෙතන omega ඒ කියන්නේ angular frequency එක තියෙන්නේ එතකොට 25 යට angular frequency එක තමයි period එක හරි දැන් සමහරවිට ඔය කට්ටියට මෙතන f දීලා තියෙන්න පුළුවන් හරි දැන් මෙතන f නම් මොකක්ද දෙන්නේ value එක f නම් එන්නේ කීයද 100 okay if you are given f can you if it is omega c is 205 radian per second, what is f? You know that f is equal to, sorry, 25f is omega. So omega is 205, and it is divided by 25, no? So f is will be 100. Okay? So maybe you will be given fc here. Okay? So what you need to do, what you need to understand is that equation. Omega is equal to 25f and f is equal to 1 over t. If you know this one, if you know these two equation, this question can be done. Okay. Now there is another signal. So you can see that if xt is a cos function with 2-volt amplitude, okay, so xt is a cos function. Now xt is a cos function, so the output signal will be xt, that is a cos function. The amplitude is 2-volt cos, what is the value? 205 t. Okay. So this is the signal now, because you know that 205, this is the cutoff frequency, this is omega, okay, and 25 cos t. Okay, so you know that omega is equal to 25f. Okay, so if you need, you can find f here. Okay, okay, so omega is 25f. Okay, now first you need to draw this signal. So you should be able to draw this signal. So how to draw this? So you know that omega is 205. If omega is 205, f is 100. Okay, if f is 100, what is t? The period. That is 1 over 100. That means 0.01 second. This is the period. Okay, so you can find the cos term. You can find the cos. You can draw the cos signal. Okay, the cos signal, you know that if time is 0, it is starting from 1, and it's like this. No, this is the cos term. Okay? So this is one period, and there is another cycle. This is another cycle. This is another period. Okay, and there is another cycle like this. Okay? So in this way, so this is the first cycle, this is the second cycle, this is third cycle, you know that. Okay? And this is one period. So what is the period? 0.01. Here, the second cycle, that means 0.02. Third one, third cycle, 0.03. And what is the value here? This is the half of a cycle, that is 0.005. And what is this value? This is a quarter, that means 0.0025 second. So you can find this value, this value, this value. This is 3/4. That means 0.0075. In this way, you can find these important points. Okay, and the marks. The amplitude is 2 volt. Okay, so you have got the XP. Very simple. Okay. සිග්නල් එකක් ඔය කට්ටියට අඳ ගන්න පුළුවන් නෝ. හරි. දැන් මේ සිග්නල් අඳින හැටි MATLAB වල එහෙම අඳින හැටි තියෙනවා ලෙක්චර්ස් වල පුළුවන් නම් බලන්න වෙලාව තියෙනවා නම්. හරි. So you can go, you need to go this signal first. Okay. Then what you are asking. Okay. So now you need to draw the volt amplitude, draw the sample waveform, margin all important point. Xt is the constant. Okay. Now you are going to sample the maximum frequency you have found now, that is 400. Okay. 405 radians per second. Okay. So here the sample frequency is not given. So that means you need to assume that you are going to, in this case, you are going to sample the signal in 405. Okay, in 405. So what you need to do is, you can very simply do it. Okay, so the sampling frequency is 405. Omega is the sampling omega is 405. That means Fs is, this should be divided by 25. That means 200. So that means the sampling time means 1 over sampling frequency, that is 1 over 200. That means, what is the value? 0.005. This is second. This is the sampling time. That means this is the time taken to get one sample. The sample time. So for example, if you get one sample here, the next sample you will get after 0.005 here. Next sample you will get, sorry, not here, here. You will get another sample. This is the first sample. This is a 0th sample. This is the first sample. And second sample you will get here. So this is the second sample. Third sample you will get here. Fourth sample you will get here. So the sampled signal will be one here, another one here, another one here, another one here. So this red color one is the sample signal. So these are the sample numbers 0, 1, 2, 3, 4. These are the sample numbers. So very easily you can do. Right? Now O-level paper again. This is just like O-level paper. You will be having 10 marks. Okay? ලකුණු 10ම ගන්න පුළුවන් ලේසියෙන්. හරි? හරි? ලකුණු 10ම ගන්න පුළුවන් ලේසියෙන්. පීරියඩ් ටික හොයාගන්න විතරයි තියෙන්නේ. ටයිම් එක හොයාගෙන ටයිම් එකට ටයිම් පොයින්ට් ටික මාක් කරන්න තියෙන එච්චරයි. Now, so you can see that. Now, the XT is sampled using 400 hertz, okay, and find the aliasing frequencies. Okay, now you are going to, so what is the signal? Okay, the signal XT is 2 cosine 205 5t. This is the signal. Now you are going to sample with this 40 hertz. Okay, 40 hertz. So this is the sampling frequency f. Okay, and if you write this xt as 2 cos, you can get 25 here. Now f is 100. No, this is the f. This is f 100 into t. Okay, so this is xt. Then next n is, okay, so you have to use this equation, okay? This one from this one. That is what you need to do. You need to get from this one, instead of ts, you can apply in ts, you can apply 1 over fs. Okay, that means f divided by fs n. Okay, so you will be having here. Now the sample fs is 400. Okay, so xn will be cos to 500. This is f divided by 40. 40, not t now, it will be n. Okay, so this is the sampled signal. This is the sampled signal. Now you can see that this normalized frequency is what? It is 10 divided by 4. That means 2.5. So it is greater than, it is very greater than half. No? So there is a Lysin effect. There is a Lysin effect. Okay. There is a Lysin effect. Okay. So now you are asked to find the Lysin frequencies. Okay. So how we find? How we find? Okay. Okay. I think I haven't. So you need to write this one. Okay. So you will be having some marks here also. Okay. And I think I haven't included it into the exam guide. Okay, actually for that one, okay, so all equations are there, okay, so you can refer this, okay. Mm, this one, okay, so you have to use this one, okay. Actually I didn't write this uh, identity. Please write this one also, okay, please write this one. So you have to use this one, okay. What is that one? Omega k, okay. Omega k is equal to omega naught. K is equal to omega naught plus 2 k5 plus 2 k5 plus 2 k5 omega naught plus 2 k5. Okay, and if you need to convert this, so this is in omega form. If you need to convert this to f, what you need to do? Omega is, you know, that is equal to 25 fk, and omega naught is equal to 5 f naught, and this is 25k. So you can see that 25, 25, 25 cancel. So you will be have, this is in omega form. This is angular frequency, and if you consider the frequency, fk is equal to f naught plus 2, f naught plus 2. Okay. So this f naught is the fundamental. So this f naught definitely should be within minus half and plus half. Okay. And if you consider omega naught, uh, to convert this omega naught, you need to multiply it by 25 here. This one from 25, This one from 4 to 5, this one from 2 5. So it will be minus 5 to plus 5. Okay, so this is given in the exam, right? But this one I forgot. Okay, please write this. මේක ලියා ගන්න. මේකත් ඕනේ නේද? හරි. එතකොට මේකෙන් තමයි ඇත්තට මේ ලයිසින් ෆ්‍රීකවෙන්සි එක හොයන්න තියෙන්නේ. එක්ක මේක හරි දාලා. හරි. දැන් අපි මෙතනදී කෙලින්ම ෆ්‍රීකවෙන්සි එක නෙවෙයි. දැන් අපිට ඇවිල්ලා තියෙනවා 10/4 frequency. So Fk is the 10/4 frequency. Okay, this Fk is the 10/4 frequency. Okay, now we need to find the F naught. So F naught, this k can be any value. K can be 0, 1, 2, 3, so on. Okay, 0, 1, 2, 3, so on. So for example, if you consider k is 1, you can find the F naught. F naught is 10 minus 4 minus 1. So it will be 6 divided by 4. Okay, you can see that 6 divided by 4 is still higher than half, no? It's still higher than half. So F naught cannot be this value, no? Okay, then you can apply k is equal to 2. Okay, so it is this should be 10/4 minus 2. So what is the value? So you will be have 2 divided by 4, no? 2 divided by 4, so that is half. So that is okay, no? So condition is satisfied, half. Okay, so so F naught will be half. Okay, half. Okay, this is half, and this will be 10/4. Okay, and so for this frequency, this one is aliasing, this one is aliasing, but this is the normalized frequency. Half is the normalized frequency. To find the actual frequency, you need to multiply it by this sample frequency. You know that frequency divided by sample frequency, this is the normalized frequency. නේ අපි මේ calculate කරේ normalized frequency එක. මේ calculate කරේ normalized frequency එක. Normalized frequency එක f කියන එක sample frequency එකකින් වැඩි කරොත් තමයි අපිට frequency එක එන්නේ. එහෙනම් මෙයා sample frequency එකකින් වැඩි කරන්න ඕන. sample frequency එක කීයද? 40යි. නේ? එහෙනම් කීයද උත්තරේ එන්නේ? අපිට එනවා මෙතන 20 Hz. එහෙනම් so what is our signal? That is 100 Hz, no? This signal is 100 Hz. Xt is 100 Hz. 100 Hz. But if you sample it through 40 Hz and if we try to reconstruct it, then instead of this 600 Hz, we will have 40 Hz signal. Sorry, 40 Hz, no? We have calculated 20 Hz signal. We will be having 20 Hz signal. So this will be a aliasing frequency. අපි හිතන්නේ මේකේ කියලා. හැබැයි අපිට අත්තට මෙන්න 20 Hz signal එක recover කරගන්න. Okay, so we need to have the 100 Hz signal, but actually we have 20 Hz signal. Right? So that is also very easy, no? Okay. So in that way, I'm sorry I have missed that equation. So you can keep remember here. Fk is equal to F naught plus k. Okay, the k is the integer 0, 1, 2, 3 like that. Okay, so using this equation you can find the aliasing frequency. So here the aliasing frequency is here. What is that? 20 Hz. It's a 20 Hz. Okay, so you will be have 5 marks. Okay, if your microcontroller sampling rate at least 500. Okay, okay, so try to do this question by yourself. Okay, so that is very this is a very practical problem. Okay, so the theory I will tell you, the theory behind it. This is a common problem. Okay, this is a common problem. That is, you know that. Okay, so you know that if we have let's say that we have a signal, we need to store this in a RAM. So you know that RAM has a limited memory, no? It is just like a memory. it has a memory bank, no? So these are referred as registers of the memory bank. Okay, like this. Okay. So let's say that this has, for example, let's say that this has 8-bit register, 8-bit register, 10 8-bit register, 10 8-bit register. That means the total memory is 18 bits. Total memory is 18 bits. Now, let's say that you want to store this signal here. So you need to convert this to digital signal. Okay. So first you need to sample this. Okay. Sample this. Then you need to convert this one sample into 8-bit binary value. So that is referred as encoding. Okay. Then you can store it here. So how many sample you can store here? Only 10 sample, no? So that means only 10 sample you can store here. Okay, store here. But I have shown that. Okay, so if you know to, if you need to store this, you need to have 10 sample. If uh, okay, 10 sample. Let's say that uh, you are selecting higher sampling frequency. That means you are getting more samples here, no more samples like this. Okay. Maybe so when the sample frequency is increasing, you are getting more samples. Okay, it is like that. If the signal is that, okay, if the signal, if the sampling frequency is twice than this signal, you will be get one sample here, one sample here, one sample here, like this. If this is 4 times, you will get another sample here also, like this. If it is 8, and you will get intermediate sample also. No? එහෙම නේ. ඒ කියන්නේ sample rate එක වැඩි කරනකොට ගන්න sample ප්‍රමාණය වැඩි වෙනවා signal එක. දැන් අපි high sample frequency එකක් select කරනවා. If we select a very high sampling frequency, what happens? So within maybe half of a circle, there may be more than 10 samples. So you can't store in this RAM, this total signal, you can't store here. Okay. So you need to have the 10 sample within this range, then you need to select the proper sampling frequency, no? To have a 10 sample only. To have a 10 sample, then you need to consider the length also, then you need to consider the sample time, then you can calculate the sampling frequency or sampling time. Okay. So in that way, you need to select the proper sampling time or sample frequency. Okay. We can't select the sampling frequency in our desire because there are some limitation in the board, no microcontroller. Okay. So I hope you understand that. Okay. That means ඔකට තේරෙනවනේ දැන් ආඩිනෝ එකක් අපි හිතන්නකො මොකක් හරි සිග්නල් එකක් ආඩිනෝ එකකට කන්වර්ට් කරන්න ඕනේ කියලා ස්ටෝර් කරන්න ඕනේ කියලා. එතකොට අපි ආඩිනෝ එකේ ඕක ඇනලොග් පින් එකට තමයි ඉන්පුට් කරන්නේ. එතකොට ඒකේ තියෙනවා ඇනලොග් ඩිජිටල් කන්වර්ට් එකක්. එතකොට ඇනලොග් ඩිජිටල් කන්වර්ට් එකෙන් මේ ඇනලොග් සිග්නල් එක ඩිජිටල් සිග්නල් එකකට කන්වර්ට් කරනවා. ඒ කියන්නේ සාම්පල් කරලා එක සාම්පල් එකක් අර ක්වොන්ටයිසින් කරලා ඉම්පෝර්ට් කරලා රෙජිස්ටර් වල මේ ස්ටෝර් කරගන්නවා. දැන් අපිට ඒ වගේ දැන් සාමාන්‍යයෙන් නම් ආඩිනෝ එක පුළුවන්නේ 500ක් විතර සාම්පල් මට මතක හැටියට. ඔය ආඩිනෝ මෙගා එක ඒ දවස්වල. එතකොට අපි high frequency sampling එකක් මේවා කරොත් එහෙම මේ අපිට සිග්නල් එකේ භාගයක් යන්නත් කලින් අර මේ sample 500 ඇවිල්ලා. එතකොට මුළු සිග්නල් එකම ස්ටෝර් වෙන්නේ නැහැ. ස්ටෝර් වෙන්නේ පොඩි sample දාන්න. හරි? අන්න ඒකයි. ඒක තමයි උත්තරේ මේක. ඒකට validate කරන්න කියලා තියෙන්නේ. So you are asking to validate the statement. So that is the answer. Okay. Okay. Now in this, so on the next time maybe I will give you to calculate the proper sampling rate. Okay. So here the validation, for the validation also you need to do the calculation. Maybe the same question I will be given. then I will maybe ask calculate the sampling rate, the maximum sampling rate to store the signal like this. Okay, so just try to understand this concept, then you can do that one also. Okay, so that is sampling. Okay, so what you need to do, first you should draw the uh, continuous signals, then calculate the sampling time, then uh, mark the sample, then using that t is equal to nts, you can convert, you can write the equation for the sample signal. So you will be given the sinusoidal signal only. Okay, sinusoidal signal තමයි ඔකට දෙන්නේ. මේක ඇත්තටම sampling of a sinusoidal signal. ඕක හරි, අර අනිත් සිග්නල් නෙවෙයි. හරි, එතකොට ඒ වගේ එකක් සාම්පල් කරපුවම එලයිසින් එන එක වෙනවා. එතකොට ඒක හොයන්න තියෙන normalized frequency එක half එකට වඩා වැඩි නම් අර equation එක දාලා හොයන්න තියෙනවා. හරි. හරි. එතකොට මෙතන අඩු මෙන්න මේ examples ටික ගන්න, try to do these examples. Okay, so I will show that example to you. Okay, so okay, so you are asking to do these examples. Okay, the very identical question will come. Okay, I think this one also I asked. So, so I think this kind of question will be. Okay, so this kind of question. So what I have explained this. Okay, so try to do this one. So the solve question is there, solved solution is there. Okay, so you can refer it. Very easy. Okay, so I think no, do this question also. Okay, I think it is not highlighted here. Do this one also, example 3.1 also in the reference book, that is in 18 pages. Okay, and I think I have asked you to do from this one, this example 4.1, 4.2, like this. Do that one also. And this one also, please try to do this one. That is 3.1, no? That is in the page 9, 18. This one, 3.1 example. Try to do this one also. Okay. So that is sampling. හරි, sampling එකත් එච්චර කරගන්න පුළුවන් වෙන්නේ නේ. හරි. ඒතකොට මේකට ඔකට ලකුණු 25ම බැරුණා පොඩි පොඩි මිස්ටේක් කරලා අඩු තරමේ ලකුණු මම හිතනවා ඔකට 20ක් 15ක් 20ක් වගේ අතර ගන්න පුළුවන් වෙයි කියලා මේ ප්‍රශ්නෙට. 25කම ගන්න පුළුවන්. හරි, එච්චර අමාරු නෑ. හරි, හිතන්න දෙයක් නෑ ඇත්තට නෑ. O level වත් there is no anything to think. Okay, there are some procedures. Okay? So if you familiar with the procedure, you can do that. Okay, so we will move to the question 3. Okay, so here first you need to find the discrete. So here there are two terms. Okay, one thing is discrete Fourier transform, other one is discrete Fourier time transform, or discrete time Fourier transform. Okay, discrete time Fourier transform. So this is two terms. Okay, so actually here you are converting a discrete time. Okay, you are converting a discrete time into frequency, sorry, time domain signal into frequency domain signal using Fourier transform. Okay, this frequency domain signal is analog signal or continuous. This omega is continuous value. Okay, continuous variable. So again there is a problem when we are going to digitally process the frequency domain. It is a problem because digital system has some discrete value. Okay, so we need to get the discrete value of this omega. For that one we use the DFT. Okay, in DFT this omega, actually we are getting frequency sample. Okay, in DFT we are getting the frequency samples. Okay, here the frequency spectrum is there. Okay, spectra is there. That means omega is continuous. But in DFT, we are getting only a discrete sample of the frequency domain signal. Okay, so that is the difference between the discrete Fourier transform and discrete time Fourier transform. There is a two lecture, I think you can refer it. You need if you need more understanding. Okay, so that is that. Okay. මෙයානම් එච්චර අමාරු නෑ ඔකට කණිම කරගන්න පුළුවන් නේ කරන්න ඕනද? Okay, I will do, for example, I will go to this one, okay. Uh, so, so this question 3, okay. So that is discrete time Fourier transform and discrete Fourier transform. Discrete Fourier transform is chapter 7, and this is in chapter 4, discrete time Fourier transform, okay. So xn you can convert to Fourier, you can convert to frequency domain, okay. And again, using the inverse Fourier transform, you can convert this frequency domain into time domain again. Okay. So in this question, you are not asking to find the inverse Fourier transform. Ask only to find the Fourier transform. That means time domain into frequency domain. Okay. So this is the equation for the Fourier transform. Very easy one. So you can see that very simply you can add. Okay. You can apply that one. Okay. For example, I write it here. Okay. So first you are given a sequence. No, the xn sequence is given. Okay. So that is a periodic signal, non-periodic signal. That means it is not repeated. So there may be some samples like this. Okay. And if you put arrow here, that means this is the zeroth sample. That means this is the -1 sample. This is the first sample, and this is the second sample. This is 3. Okay. So for example, if you are given this kind of sequence, okay, in exam you are given this kind of sequence. Okay. So if you draw this, n versus xn, the zeroth sample is 1, x0 is 1, this is x0, that is 1, x minus 1 is 2, sorry, x0 is -1, x0 is -1, that means here -1, x now x minus 1 is 2, the -1 sample is 2, the first sample is 0, the second sample is 3, like this. Okay, so this is the uh, discrete signal. Okay, discrete signal, and you can, this signal can be given as a sequence also. If you put here arrow, that will be the 0th sample. Okay. So for example, if you are given this kind of one, what you need to do? So you need to use this and expand very simply. Okay. So x omega is for this one, x omega is, now you can see that n is from n, the limit of n is, that is from -1 to 2. No, this is n is from -1 to 2. So it is -1 to 2 here. Right? තේරුණා නේද? ඔකට දැන් මෙහෙම 2 ඍණ 1 බිංදුව 3 වගේ සීක්වෙන්ස් එකක් දීලා මෙතෙන්ට මේ ඊටලයක් දැම්මොත් එහෙම මේ කියන්නේ බිංදුව වෙනි සාම්පල් එක. ඒ කියන්නේ සිම්පල් වෙන් බිංදුවයි මෙතන. මෙතන සිම්පල් වෙන් කියන්නේ ඍණ 1යි. මෙතන සිම්පල් වෙන් කියන්නේ 1යි. මෙතන මේ දෙවනි සාම්පල් එක. ඒක ඩ්‍රෝ කරොත් මේ විදිහට. This is the zeroth sample, 0, 1. This is the -1 sample, that is 2. Okay, and this is the first sample, that is 0. And this is the second sample, that is 3. දැන් එතකොට මේ සිග්නල් එක තියෙන ඍණානන්තේ ඉඳන් ධනානන්තයට නෙවෙයි. So this signal is not -infinity to +infinity. It is from -1 to 2. N is from -1 to 2. So n is from -1 to 2. n කියන එක ඍණානන්තේ ඉඳන් ධනානන්තයට ඕනේ නැහැ. මොකද මේකේ තියෙන්නේ ඍණ 1 ඉඳන් 2 වෙනකම්. එහෙනම් මේක ඍණ 1 ඉඳන් 2 වෙනකල් එක්ස්පෑන්ඩ් කරන්න තියෙන්නේ. n කියන එකට ඍණ 1 2 දාලා. ඒක කොහොමද ඉන්නේ? x omega කියන එක සමානයි. First, n is -1. That means x -1 e to the power -j omega. N means -1 plus channel. Now it's x omega is given as in from -1 to 2 xn e to the power j omega n minus j omega n. So x omega we can write as, this is n from -1 to 2, no? X minus 1 power minus j omega n is -1 plus x x0 e to the power minus j omega n is 0 plus x1 e to the power minus j omega 1 plus x2 e to the power minus j omega 2. Yeah. X minus 1 කියන්නේ දෙකයි නේ, x minus 1 කියන්නේ දෙකයි, x0 කියන්නේ ඍණ එකයි, x1 කියන්නේ බිඳුවයි, x2 කියන්නේ ඊයද තුනක් දෙකෝදනේ අපි දන්නේ. xn කියන එක එහෙම නේද ගත්තනේ, xn කියන එක ගත්තේ දෙක ඍණ බිඳු මේක 0. Now 0 sample. So x0 is -1, x minus 1 is 2, x1 is 0, x2 is 1, x2 is 1. This is x omega. Okay, so very simple. And so I think you can do that one. Okay, you can do that one. And this one also you can find the first, you can find the sequence. For example, you can apply in 0 1 2 3 here. 0, you can put 0, then sign 0 value. You can put 1 here, then 5 by 3 value. You can put 2 here, then value. You can put 3 here, you can find the value. So you can see, you can get this kind of sequence here also. Okay, this kind of sequence here also. Then using that equation, you need to expand it. Okay, so you can do this one also. Okay, and the DFT, this is the discrete Fourier transform. Okay, so that is also very important. Actually, this is referred as endpoint DFT. Okay, so here the equations are given. Okay, so this is the discrete Fourier transform equation. Okay, this is the Fourier transform equation. I will write it here. So xk is equal to, so very easy. Okay, this time the paper is very easy. N from 0 to n minus 1, n from 0 to n minus 1, it's n e to the power n divided by xn e to the power minus j 5 kn divided by n. So this is you need to find. Okay, so this is very easy. So you will be given a sequence xn. For example, you will be given 1 2 3 4 in this way. Okay, and let's say that the mark is here. The mark is here. Okay, so this is the 0th sample. This is the first sample. This is the second sample. This is the third sample. That means this is x0, this is x1, this is x2, this is x3. This is the 0th sample, first sample, second sample, third sample. Okay. So this L is the length of the sequence. That means here 1 2 3 4. The length is 4. Okay. So for this frequency, for this signal, for this sequence, the sequence length is 4. So L is 4. Okay. And N is the, so normally this is referred as endpoint DFT, NDFT. Okay. Now you are asking to calculate first 4 DFT, no? You asked him to calculate the 4 DFT in the model filter. Okay. See, 4-point DFT. 4-point DFT means you need to select, you need to get 4 frequency sample. This n is here. The n is not the period. Now period this is not the period. This is not the period. This is the number of frequency sample. This is the number of frequency sample. This is the number of frequency sample that is 4. තේරුණාද? මෙතන මේ n කියන්නේ period එකේම නෙවෙයි frequency sample ගන්න. ඒක තමයි අපිට කියන්නේ මේ 4-point DFT කියලා කිව්වොත් එහෙම ඒ කියන්නේ frequency sample 4ක් හොයන්න කියලා කියනවා. So if we are asking to find the 4-point DFT, that means we are asking to find 4 frequency samples. Okay, 4 frequency samples. Okay. So this K, okay, now actually here this K, okay, this should be K, and so here it is N, okay, N from 0 to L minus 1 because here the N, okay. Now the K value should be 0, 1, 2 up to N minus 1. Okay. So if you are asking to calculate 4-point DFT, okay, that means there are 4 samples, so it is starting from 0. So K will be 0, 1, 2, N minus 1 means 4 minus 1, so that is 3. Okay. So you need to get 4 frequency samples, 1, 2, 3, 4. So the K should be 0, 1, 2, 3. Okay. Now you need to find the frequency sample, very easy. So first C frequency sample, actually 0 frequency sample, that is K is equal to 0. So what is that? X0. Now K is equal to 0. Now sigma n from 0 to L minus 1. L is the number, the length of the signal. So length is 4. 4 minus 1, that is up to 3. Xn e to the power minus j to 5. Now K value will be 0. K is 0 because you are finding K is 0. So K value will be 0 divided by n is 4, the number of samples, okay, divided by 4. So now this is multiplied by 0, so e to the power 0, the whole term will be 0, e to the power 0 means that's no value. So you have to expand this. So x0 plus x1 plus x2 plus x3. So x0 is 1, x1 is 2, x3 is the third, x2 is the second sample, 3, so we get as xn as 1, 2, 3, 4, and this is the 0th sample. This is the 0th sample. If you put the arrow, that is the 0th sample. So that means okay. So that means this is the 0th sample, this is the first sample, this is the second sample, this is the third sample. So this is N0, N1, N2, N3. Okay. So our xk is sigma L from 0 to L minus 1, the length of the sequence, so that is 4, xn e to the power minus j to 5k n divided by n. So this L is the length of the sequence, so that is 4. N is the number of frequency point, so that is also 4. Let's say that we are asking to find the 5-point DFT. So N is 5. Okay. Now N is 5. Okay. So this k, the value of k will be 0, 1, 2, so on up to 4 minus 1. Sorry, n minus 1 up to n minus 1. So n minus 1 means 4. So k will be 0, 1, 2, 3, 4. So you need to find 5 frequency sample. 5 frequency sample. For example, if you select k is equal to 0, that is the zeroth frequency sample, that is capital X 0. So that will be sigma n from 0 to L. L means the length of the sequence, that is 1, 2, 3, 4. So it will be 4 minus 1. So it will be 3 xn into the power minus k to 5 kn. Now k is 0. K is 0, simple n. The capital N is 5. Capital N is 5. I consider 5-point DFT, okay? I consider 5-point DFT. So there should be 5 frequency samples, okay? So anyway, this is multiplied by 0. So this whole term will become 0. So you will be having x0 plus x1 plus x2 plus x3 to x3. So x0 means 1, x1 means 2, x2 means 3, x4, x3 means 4. So what is the value? 1, 2, 10. So this is the zeroth frequency sample. This is the zeroth frequency component. Frequency component. Actually, here this is the value of hertz. Okay, zeroth frequency component. Sorry, sir. This is the value of voltage. Okay, the zeroth frequency will be this will be this will be. Oh, this is the zeroth frequency component. Okay, so this is the frequency actually. This is the frequency. So this is the zeroth frequency component. So that is 10. Okay. Then you need to find the first frequency component. So that is k is 1. For that one also, you uh, expand this xk, capital Xk. So that is from n from 0 to 3 xn. Now e to the power minus j to 5. Now k is 1, n is there. For the capital N is 5. Okay. So you will be have this one. So now you need to expand this. So plus x0. So n is 0. So e to the power 0. So it will be 1. x1 e to the power minus j to 5. This is 1 and n is also 1. So 2 5 divided by 5 plus x2 e to the power minus j 2 5. This is 1 and n is 2 now. So 2 5 in 2 into 2 5, that is 4 5 divided by 5 plus x3 e to the power minus j. Now n is 3. So 3 into 2, that will be 6 5 divided by 5. Okay. So x0 is 1, x2 is, x1 is 2, x3 is, x2 is 3, x3 is 4. So you can find the xk and xk. Okay. So this is the uh, first frequency component. This is the first frequency sample. This is the first frequency sample. So on you can find the second frequency sample, third frequency sample, and fourth frequency sample. So 0. So you can find x0, capital X1, capital X2, capital X3, and capital X4. So that means 1, 2, 3, 4, 5 frequency sample. uh, and so you can see that here also the same thing you need to do. You can apply the value of n here, then you can find the sequence in this way, then you can find the 4-point DFT. Actually, 6-point DFT is also the same way. Okay, this zero padding means, okay, this zero padding means uh, for the 6-point, actually here we have 1, 2, 3, 4, 5, 6. So 6-point of xn. So here, for example, here we have only 1, 2, 3, 4 samples. No? Zero padding means at the end of the sequence, you can add some zero. You can add some zero. Then you can calculate. Okay, you can calculate. So adding the zeros is not much difficult. Okay, for example, if you are asking to, for example, if you are given a sequence like 1, 2, 3, 4, and if you ask to calculate the um, calculate the 6-point DFT or something, 7-point DFT or something, 7-point DFT something. Okay, so here you have 1, 2, 3, 4. No, so maybe you can add 3 samples. Actually, if you haven't add this 3 sample, it will not affect. Okay, making this effect happen. මොකද ආපහු මේ වගේ වැලියු එක 0 නේ ඔකට ආපහු 7 වලට යන කල්ම හදනවා ඒ වුණාට ඉතින් මේ වගේ වැලියු එක 0 වැඩක් නැහැ ඊට වඩා හොඳයි ඔන්නම හදන එක හරි so that is zero padding okay. මම හිතනවා මේ ගානක් ඔකට ලකුණු 25ම ගන්න පුළුවන් වෙයි කියලා ලීසි ගන්න 25 marks you can do here also හරි so on the exam guide I have asked you to do two example 1.2 and 1.3. So these are easy example. Please try to do that one also. Okay. And question 4 actually filter designing part I'm not going to discuss here because you need to go through that 2 lecture. Okay. For these 2 parts, please go through that lecture. And this part actually this is you know that that is a linear time invariant system. You need to know that. Okay. So linear means I have explained this. Okay, linear. Actually, in that lecture too, this is discussed. Okay, linear means system is linear. That means if you are given a signal, let's say that x1 and another signal x2. Let's say that for the x1 the output is y1 and x2 the output is y2. And next one is has one weightage and this this mother signal has another weightage in this way. So the output also will be with that weightage and with that output. So that system is referred as a linear system. Okay. So that means the same weightage and same signal addition will be there at the output. Okay, so that is linear. Time invariant means if you input the signal with some time delay, the output also has the same time delay. Same time delay. So that is referred as a time invariant system. So that is the condition. So this one and this one. These two are the condition for LTI, linear time invariant, linear time invariant. You know that for a linear time invariant system, LTI system, okay, the input is referred as Xn, output can be referred as Yn, and there is another things that is Hn. This Hn is referred as impulse response. Impulse response means if we given an impulse to the system, impulse delta n, the output, it is referred as the impulse response. So that means if we give a delta n impulse, the output will be hn. That is referred as impulse response. Okay. For a linear time invariant system, output is equal to input in convol by hn. Okay. So this is the convolution. This is not a normal multiplication. This is a convolution. Okay. This is a convolution. So convolution, calculating convolution is somewhat difficult. Okay. But there is another way to calculate this yn. So maybe you are given xn and hn. So you are asked to calculate the ya. Okay. So the convolution you don't know to perform. So it is somewhat hard. Okay. So that one you can see do like that. You can get the Fourier transform of yn. So you know how to do it now. We have discussed it. A discrete time Fourier transform you can get. Then you can convert this to y omega, and you can get x omega also. That is, you can convert to x omega. H omega also you can get Fourier transform of xn, hn. So that is h omega. Then once you convert this time domain signal into frequency domain, this convolution will be simple justification. So what you can do is, you can get the Fourier transform of x1, you can get the Fourier transform of hn, then you can multiply that. Okay, so that you can calculate the y omega. Actually, to calculate yn, you need to get the inverse Fourier transform of y omega. Okay, so that is you have to do integration. Okay, so maybe that part not come to the exam, but it is also not difficult. Okay, so to find the inverse Fourier transform, actually you have to apply this equation. Okay? Apply this equation, you can at least, if I given that question, just write this identity. If you couldn't evaluate the integration, so this integration will not be difficult. Okay, the exponential terms will be there. හරි, exponential terms නෙන්නේ. එතකොට exponential terms වල එකතුවක් එන්නේ. එතකොට ඒක integration එකත් ඔය කට්ටියට පුළුවන් මේ solve කරගන්න. හරි. engineering student ලට නම් මේක ඉච්චර අමාරු නෑ, කරගන්න පුළුවන්. හරි. ඒ වුණාට ඔය කට්ටියට බැරිලත් මම මේ වගේ ගානක් දුන්නොත් මේ විදිහට කරා. මේ කියන්නේ අර දෙක කන්වර්ට් කරන්න ෆ්‍රීකවෙන්සි ඩොමේන් එකට ඊට පස්සේ ඉන්වර්ස් එක ගන්න තියෙනවා. ඒකට ඉන්වර්ස් එක හොයාගන්න බැරි වුණොත් මේ ඉක්වේෂන් එක හරිය ලියලා තියන්න. හරි. Just try to write this equation if you couldn't find this, if you couldn't solve this. Okay, this is the integration. So that is very simple. Okay, for example, we have found some Fourier transform. No, it is not here. No. Okay, we have found some Fourier transform. So you can see that maybe you can remember that we get this kind of one. No? We get once you got the Fourier transform, we get 1 e to the power minus j pi by 2 omega plus 2 e to the power minus j pi by 2 pi by omega, like this kind of terms. No? Okay, so for the inverse Fourier transform, you need to multiply this x omega by e to the power j j omega n, then integrate this d omega with respect to 1 over n. Yeah, okay, I can't remember. Okay, so you need to integrate this and multiply it by with e to the power j omega n. Then this one and this one will be adding. Okay, so you have to integrate this exponential terms with respect to omega. So you know that ex integrate dx. So you know this one. So that is ex divided by a. Okay. So like this, you will get some terms here. Okay. So then you need to apply the apply the limits n from 0 to something. Okay. then n of omega from 0 to up to something. Okay, so you will have some terms with n value. Okay, so that is also not much difficult. So, so this question also I hope you can do. And this one, please refer the paper. Okay, please refer that two examples. Okay, so if you have any problem, if you have any problem, you can ask. If you have any question, you can ask. Otherwise, we will conclude the day. Yeah, yeah, you can bring this open book exam. Okay, so you can bring. Please bring all the notes. Okay, you can't remember the equation or equation මටවත් මතක නැහැ. හැම අවුරුද්දම උගන්වන සබ්ජෙක්ට් එකේත් මට මතක හිටින්නේ නැහැ ඔය equation. හරි. ඒ equation එක apply කරන එක තමයි වැඩේ. Okay, okay. I will upload this. Okay, don't worry. I will upload this. Okay. So if you haven't any problem, we can conclude the session now. Shall we conclude the session?